Dynamic Market Mechanics, DMM, a dynamic physical model for price movement. Core concept. The market is not a battle between buyers and sellers. Every transaction has both a buyer and a seller. The real conflict is between the forces attempting to move price and the market's resistance to that movement. Therefore, price movement emerges from the interaction of four fundamental variables: energy, mass, time, rigidity, which is liquidity. When these four variables are in equilibrium, price remains relatively stable. When one or more variables move out of balance, the market begins searching for a new equilibrium. Sometimes this transition is gradual. Other times it occurs as a rapid collapse known as a cascade. The analogy: imagine a tug-of-war competition. Each side has a team. However, every participant is different. Each person has weight, strength, endurance, balance. For this reason, the winner cannot be determined simply by counting the number of people on each side. The market behaves in much the same way. 1. Mass. Mass represents the amount of committed participation within the market. It can be approximated using trading volume, average volume, open interest, when available. High mass means that a significant amount of capital has already committed itself. As a result, the system develops inertia. Like a fully loaded truck, it becomes difficult to accelerate or change direction. Low mass means that relatively little capital is committed. The system becomes light. It is easy to move, but it is also easy to reverse. Example: imagine a tug-of-war between 100 people versus 90 people. Although one side has an advantage, both teams are large. The combined mass is high. Movement is slow and difficult. Now compare that to 5 people versus 4 people. The proportional advantage is identical, yet the total mass is much smaller. The rope moves much faster. Inertia. Mass does not create movement. Mass resists change. Therefore, more mass is not equal to stronger trend. More mass equals greater stability. 2. Energy. Energy represents the amount of effective work being performed. In financial markets, energy is not simply volume. Instead, it measures how efficiently volume succeeds in moving price. In other words, price movement per unit of volume. It reflects the true effectiveness of buying or selling pressure. Examples: suppose 2 trading sessions have identical volume. During one session, price rises by 3%. During the other, price rises only 0.2%. In the first case, energy is high. In the second, most of the effort was absorbed by opposing liquidity. Energy is low. 3. Time. Time is not measured by the clock. Time represents the lifespan of a force. The longer a force continues acting, the more fatigue it accumulates. Just like an athlete, strength is never infinite. Even powerful trends eventually weaken. Example: 2 teams begin pulling the rope. One team is stronger. Initially, it dominates. However, after sustained effort, fatigue begins to accumulate. Eventually, even the stronger team can collapse. 4. Rigidity. Rigidity describes how difficult it is to move price. Its primary source is liquidity. Imagine compressing a spring. A stiff spring requires significant force. A soft spring requires very little. Markets behave similarly. Sometimes enormous energy produces only a small price movement. Other times, a small amount of energy produces an explosive move. Why does price move? Price does not move because there are more buyers than sellers. Price moves because the force applied exceeds the market's resistance. In simple terms, energy, rigidity, mass oscillation. Large institutional participants rarely reveal their intentions. Buying an entire position at once would expose their activity. Instead, they distribute execution over time. Their objective is to remain close to the market's normal participation level. Consequently, mass naturally oscillates around its average, neither excessively high nor excessively low. Once accumulation or distribution is complete, the equilibrium breaks, allowing price to begin its next major move. Energy oscillation. Energy also oscillates. If every participant pulls with maximum effort continuously, fatigue arrives quickly. Instead, markets naturally alternate between push, rest, push again, rest again. This creates a natural pulse within the market. Polarity. One of the market's most important characteristics is polarity. A leveraged position is not merely force. It is also stored potential energy. Most leveraged positions include a stop loss. When the stop is triggered, the position effectively changes direction. A closed long position becomes market selling. A closed short position becomes market buying. Therefore, every leveraged position contains future directional energy. Cascade. Return to the tug-of-war analogy. One team is pulling with maximum force. The opposing team maintains resistance. Suddenly, the weaker team briefly releases the rope. Resistance disappears. The stronger team loses balance and falls backward. At that exact moment, the weaker team begins pulling again. The stronger team is already on the ground. The contest is effectively over. Financial markets behave in much the same way. Each triggered stop order adds additional force in the same direction. That additional force triggers more stops. Those stops trigger even more. A domino effect emerges. This is not linear movement. It is a chain reaction. Three fundamental market states: low energy. Mass exists, but insufficient force is available. The market consolidates. Excess energy. Force becomes excessive. The trend appears powerful. Ironically, this is often where collapse becomes most likely, because most available energy has already been spent. Dynamic equilibrium. Energy alternates naturally. Mass remains stable. The market maintains healthy oscillation around equilibrium. The life cycle of a trend. Quiet market. Accumulation. Gradual energy build-up. Breakout. Public participation. Energy saturation. Stop clusters form. Cascade. Exhaustion. Distribution. Return to equilibrium. The fundamental law. Markets continuously seek equilibrium. However, equilibrium is not a fixed point. It is a dynamic process. As long as changes occur in mass, energy, time, liquidity, equilibrium itself continues to shift. Consequently, price continues to evolve. Conclusion. Price does not move because there are more buyers than sellers. Price moves because a dynamic system composed of mass, energy, time, and rigidity temporarily falls out of equilibrium and continuously seeks a new state of balance. Every trend is the result of accumulated energy. Every correction is the release of stored energy. Every cascade represents a phase transition in which potential energy is released almost instantaneously. Ultimately, financial markets are neither completely random nor perfectly deterministic. They behave as nonlinear dynamic systems, continuously oscillating around a moving equilibrium, where every change in mass, energy, time, or liquidity reshapes the state of the entire system. In conclusion, markets are not driven by price. Price is only the visible result. The real story is written by mass, energy, time, and liquidity. When you learn to read those forces, price stops looking random and starts looking like physics.